In this video, we're going to discuss confidence interval for still population mean when population standard deviation is unknown. So population standard deviation is not given in the problem. So from the formula sheet, we're doing this right now. Confidence interval for estimating population mean when population standard deviation is unknown. Right here. So we have to use this formula. But let's go over some basic concepts first. So previously we showed that we showed how to construct confidence interval for mean. We're still dealing with the mean here, population mean, estimating population mean. For normal population, when population standard deviation is known, sigma is known. In this case, we used sample mean plus minus critical value. We also use z of c. You need to be comfortable with both notation, alpha divided by 2 or z of c, times by standard errors, population standard deviation divided by square root of n, and n is the sample size. But in practice, it is more common that population standard deviation is unknown. It's not given. Unknown. Not we actually don't know in a lot of real data. When we don't know this value, we replace it with sample standard deviation. Note that we can always calculate sample standard deviation in any data set we collect. So in this case, we use student t distribution. So let's talk about what student t distribution is. So we're not using normal distribution, we're using student t distribution. It is symmetric and has only one mode. It is more spread out than the standard normal distribution. And if you increase the number of degree of freedom, which we'll talk about in a second, but you can think this as if we increase the sample size, essentially, the student d curves becomes closer to the standard normal curve. There are many different student distribution, but this different distribution distinguished by degrees of freedom. Degrees of freedom. So what is degrees of freedom? When constructing a confidence interval for population mean, number of degree freedom for student t distribution is one less than sample size n. So essentially, we do just sample size minus 1. Then we get degrees of freedom. And I'll show you when we're going to use this degrees of freedom when we find a margin of error. So when the population standard deviation is not known, again, this is a very important part right here. This is something that as you read the problem, you need to be able to recognize, oh, population standard deviation is not given in the problem. Then we use T or TC, T alpha over 2 or TC. These are called critical value. Again, both of these mean the same thing, critical value. Instead of Z critical value. To find T critical value, we use a critical value for student T distribution. So we use this table, which is given in the next page. And, oh, sure, it should be not previous, next page, next table. And the largest number of degrees of freedom is 1,000. So if the 1,000 is not on the table, for example, if the desired number of degrees of freedom is less than 1,000 and is not known in the table, we use the next smaller degree of freedom. If desired number is more than 1,000, then we can use the Z. We can assume the sample size is big enough to use Z table. So let's look at the Z table together. Excuse me, I mean T table, T critical value table. So here's a T table. Okay. So for us, for now, we're only looking at this part right here. This part. So these numbers. Well, these are the numbers that we'll be finding using degrees of freedom. So for example, if sample size was 9, then degrees of freedom, df, that's what df is for, and corresponding critical value, that's what c is for, is n minus 1, so it'll be 9 minus 1, which is 8. So then for us, we look at this entire row of 8. And if we want to find confidence interval of something estimating population mean with 90%, let's say 90%, then this will be the uh, critical value. This will be the T of C value, 1.865. For 95% confidence interval, we use this. For 99, we use this as a critical value. So this is just another way of finding critical value because we cannot use z-table when population standard deviation is not given. Okay, so let's look at some practice. Note that the critical value, T of C, depends on both confidence level, which should be provided in a problem 90%, 95, 80, 85, 99%, and degrees of freedom. We usually have to calculate it every time, each problem. So it's different from normal table where we can just refer to the same table every time. We have to actually find it from the table each time. So find the critical value needed to construct confidence level for given level of the sample size. So we're practicing using the table first, and then we'll look at the full problem. So here, level is 90%. So level is 90%. And sample size is 6. So then degrees of freedom is n minus 1. In this case, 6 minus 1, therefore 5. So we look at 0.9 and 5. So let's go to the table. So first, our degrees of freedom is 5. So we look at entire row right here. You can see my hand right here. And since it's asking 90%, 90% is here and 5. So this would be the critical value, 2.015. 2.015. 2.015 is the critical value for level 90% with sample size 6. So let's try the next one. Level 98% with sample size 12. Well, 98%, 0.98. And degrees of freedom is 12 minus 1, which is 11. So we need to look at 11 and 0.98. So let's actually go to the table that I wrote it here. 11 and 98. So 11's right here. And 98% is right here. Let me use different color. Let me highlight it with blue. So 11 and 98. So this one right here is the critical value for this problem. 2.718. 2.718. So why don't you pause this video and try this one on your own? Okay, pause the video now. Okay, so let's try. Degrees of freedom is n minus 1, so it'll be 10 minus 1 will be 9. And we're looking at 0.99. So degrees of freedom was 9, and we're looking at 0.99. So it will be right here, 3.25. Be careful, this is 0.999. But we're looking only at 0.99, 90%, 99%. So answer is 3.25. 3.250. And let's go back to the table. If degrees of freedom is not given, let's say degrees of freedom of a problem was, let's say, 39 in our problem. Our sample size was 40, degrees of freedom 39. But then we use actually 35, the smaller, the closest to smaller one. So if degrees of freedom was 39, we use 35 to find the value. If degrees of freedom was, let's say, 800, bring it up. 800, but 800 is not here. But then we use 500 and find the corresponding percentage of confidence interval to find a critical value. So let's look at this problem. Sample size of N22 is drawn from a normal population. Find a T critical value. Again, we use both symbols, TC or T alpha over 2. Needing to construct 90% confidence interval. Well, degrees of freedom is 22 minus 1, which is 21. And we're looking at 0.90 confidence interval. So let's go to the table. It was 21 right here, and 99.90 is this one right here. So it will be 1.721. 1.721. Oops. Let's use a pen, not a highlighter. 1.721 is the critical value. If the sample size was 15, would the critical value be smaller or larger? Well, let's find it. Just compare. So n equals 15. So degrees of freedom, n minus 1, which is 15 minus 1, gives us 14. So let's look at 90% and 14. 90%, 14 is right here, 1.761. So it is larger. 1.761. It is larger. Okay. Well, larger essentially means that we'll have a larger margin of error. So in general, of course, the more sample size we have, less margin of error we could have. Okay. So what we just did is in this formula, we just practice how to find this value when we calculate margin of error, just this value, because we have to use t-table. And S means sample standard deviation, which we can calculate given any data, and N is a sample size. So let's see how we can use this to find confidence interval of population mean when population standard deviation is unknown. So if you read right here, constructing a confidence interval for population mean when standard deviation is unknown. The reason we say just standard deviation here, standard deviation is unknown, is because population standard deviation, known or unknown. Because sample standard deviation can be always found. So here, maybe I can just write it here. This means population standard deviation. And you can always refer to the formula sheet as well, because formula sheet will also say either population standard deviation, known or unknown, which is the symbol sigma. So let's look over the steps. The following must occur. We have a simple random sample. Either sample size is large or population is approximately normal. And compute the sample mean and sample size deviation, S, if they're not already given in the problem. And then find the degrees of freedom and the critical value using the t-table. T-table. Of course, t-table is provided. It's not something you need to memorize. And find the standard error and find the margin of error. That's the margin of error formula. And confidence interval is similar from what we did previously. Subtract from the point estimate sample mean, margin of error, add margin of error to point estimate. Remember, sample mean is point estimate. This is a point where we can begin to estimate. And from the point estimate, we subtract, add population mean. So let's look at some examples. Sample size of N44 has sample mean of 56.9 and sample standard deviation of 9.1. Construct 98% confidence interval for a population mean. So first, point estimate is 56.9. This is the estimate, but this is just a 1 point. From here, we add and subtract margin of error. So then let's find margin of error. Margin of error. Let's write down the formula. Let me go back to the formula. Is this right here. E equals TC times S over square root of N. Well, these two values are provided. We can always, well, sample size must be provided because that tells you the sample size. And sample size deviation, we can always calculate it, or in this case, it's given in the problem. Right here. Right here. So then we need to find this critical value. We want to find this, the degrees of freedom is n minus 1, which is 44 minus 1 is 33. So using 33 and 98%, we need to find the critical value. So let's go to the table. 98%. Well, let's look at degrees of freedom first. Degrees of freedom is 43. 43 is not here. Right? So that means we use one smaller one. Closest, always smaller. Even if 43 is closer to 55 than 40, we always use smaller one. So look at 40, look at this row. From here, we get 98%. 98% is right here. 2.4323. 2.423. This one is at 40, and this is at 98% column. 2.423. So this value we found to be 2.423. That's the critical value. Times sample standard deviation is 9.1 divided by square root of 44. Sample size was 44. If you calculate this, you get something close to 3.3. So that's the margin of error. So, kind of run out of room here. Let me actually finish this problem here, and I can do the B. I'll do the B right here. So, the confidence interval is sample point estimate minus margin of error, point estimate plus margin of error. Well, sample mean is 56.9, margin of error 3.3. So this is very similar to what we did previously. Only thing really changes the way we calculate the margin of error. So the population mean is between 53.6, 60.2. So we are 98% confident that the population mean is between 53.6 and 60.2. So the part B asks us, if sample size were 30, would the confidence interval be narrow or wider? So sample size is less. So if this is not intuitive, we can just try. Well, then degrees of freedom is n minus 1, which is 30 minus 1 gives us 29. And with 0.98 again. So let's find the margin of error, because we're trying to calculate the margin of error. So let's find the critical value at 29 and 0.98. Yes, 2.462. 2.462. That's the critical value. Multiply by 9.1 divided by square root of 30. Well, just comparing these two values, this below one, with the sample size 30 is bigger, right? That means margin of error is also bigger. Margin of error, if I calculate this, I get about 4.0. So margin of error is bigger. That means that the confidence interval will be also bigger or wider. So answer is wider. It'll be wider. And this is just to highlight that smaller sample size we have, the bigger the confidence interval will be. Or we can say the bigger the sample size, smaller the confidence interval. The narrower is better, right? Because we want to pinpoint the population mean when we estimate, right? So the better as in is probably more accurate the more sample we have, which means the narrower the confidence interval, more accurate the population mean we can estimate. So let's look at another example. In a sample of 77 children, n equals 77, the mean age at which they first began to combine words was 16.51 months. So this was sample mean. We know this is sample mean because it's from sample of 77. with a standard deviation of 9.59. Again, we also know this is sample standard deviation because it's coming from 77. So this is sample standard deviation. So from reading this problem, we need to be able to recognize this is with population standard deviation not given, unknown. So it's very important when you read the problem to identify which formula to use. Here, we are trying to estimate population mean, and population standard deviation is unknown. So we have to use this formula. So construct 95% confidence interval for mean age of which children first begin to combine words. Okay, so first, we find the point estimate. Here is given point estimate. Point estimate is 16.51. Sample mean. From here, we add and subtract margin of error. So let's calculate the margin of error. Margin of error is critical value times S sample size deviation divided by square root of n. So let's find the critical value. Degrees of freedom is 77 minus 1, 76. So we need to be careful. It is 76, not 77. 76 and 0.95. 0.95. So critical value, let's go to the table. 76 is not here. So that means we have to number closer to 76. That is smaller. Smaller. So 76 is not here. So we look at 70. And 95 is where? 95 is this one right here. So 1.994. So 70, 1.994. That's a close to 1.994. So this one is 1.994. This is the critical value. Critical value. Multiply by standard deviation, sample standard deviation given in the problem. In this case, we can always calculate given the data. Divide by square root of 77. So we just calculate this to find the margin of error. And this gives us about 2.18. About 2.18. That's the margin of error. So for the confidence interval, again, same idea. This is what we're doing. We are estimating population mean. Right? That's what we're trying to estimate. Mean is between two number. So we just add this number from 16.51. 16.51 minus margin of error. 16.51 plus margin of error. So then we get 14.33 and 18.69. So this is the confidence interval for the population mean. We're 98% confident that the mean age at which children first begin to combine words is in between 14.33 months and 18.69 months. So B, if sample of 50 had been studied, would you expect the confidence interval to be wider or narrower? Well, let's assume that sample mean and sample size deviation is same. Right? But in that case, then because sample is smaller, the margin of error will be bigger because the critical value will be bigger. And we can test it by actually finding the critical value. Degrees of freedom is 50 minus 1 is 49. With a 49 with 0.95% confidence interval. So critical value, let's find that. T of C, 49 is not here. So we look at 45, the smaller one, closest to smaller one. And 95 is, let's see, 95, that's right here. 2.014. 2.014 is the critical value. So if you look at it, just comparing this critical value and this critical value, that's not a good question. Let's do this. 2.014 is bigger. That means margin of error for this scenario, 50, sample will be also bigger because we're multiplying bigger number when we calculate margin of error. So let's just calculate margin of error just for practice. Will be this value, critical value times 9.59 for the sample standard deviation divided by square root of sample size. It's actually the same as this one. And I get about 2.74. So margin of error is bigger than this one. Therefore, this will be wider. The confidence interval will be wider. The range will be bigger because margin of error is bigger. So something to just keep in mind in general, the sample size, you want bigger sample size. So let me sum up. For this problem in this lesson, we looked at this section, how to estimate population mean. Mu means population mean when population standard deviation is unknown. We use t as a critical value when calculating margin of error. And in order to find t value, we look at t table with the corresponding degrees of freedom and here given confidence interval. df means confidence interval, c means critical value, so we're looking at these as a percentage given.